Hi, my name is Bradley Mitchell. I'm a Senior Project Manager working for Eco-living Ltd. Eco-living Ltd was formed in 2012 with a view to provide a solution to the growing need for new build homes within the United Kingdom, as well as addressing the needs to build a sustainable future for our planet's fragile environment. This video has been produced to provide an overview of the current Eco-Village project that is being undertaken by the core design team that is made up of civil, coastal and mechanical engineers, as well as demonstrate the capability of Eco-living Ltd to act as a consultant during the implementation of the current project. To date, the core design team that I am working with has produced a number of detailed designs in relation to a proposed eco-village that is to be situated on the southwest coast of the United Kingdom. This eco-village is to provide sustainable accommodation for up to 2,000 residents and even produce its own form of green electricity. Each member of the core design team is responsible for a key aspect of the project. This has produced defined structure within the team's dynamic. The design of water management for the eco-village project has been undertaken by Scott Wolford, who is a member of the civil design team. The lead designer for the residential accommodation is Philippa Carter. She is a member of the structural design team and also acting as the group secretary. Mechanical design has been undertaken by Shane Crowley, and he has taken the lead on the design and implementation of the green energy generation for the entire eco-village project. All public buildings have been outlined by Ali, who is a member of the structural design team. The final site layout and the required infrastructure for the entire village has been undertaken by David Molnar, who is a member of the civil design team. The Eco-Village, which is to be located near to Mothecombe, approximately 12 miles from Plymouth, has been designed to promote a feeling of community spirit. This has been achieved by keeping all amenities such as a town hall and pub at the centre of the village. It should be noted that these have been designed as shell elements only, taking into account the plant area required and producing first stage cost estimates, as well as the estimates for the specific energy requirements. The infrastructure design for the village includes outline designs of combined heating and power plants and sewerage plants, as well as road design and the design of street lighting, to name but a few of the elements. The school, which is located near to the centre of the village, has been designed as an outlined structure, such as stating the materials to be used and the key structural elements. The housing, which has been designed in detail, is to radiate from the centre of the village, with no section of the housing being completely separated from the overall community. Further to this, area for further expansion has been identified. The tidal energy generation system, which has been designed in detail, is to be located to the west of the village in the River estuary. Following the guidelines set out by the South Hams District Council, the proposed 927 new dwellings for the eco-village will comprise of 255 executive homes, 208 mid-range homes, 464 affordable homes, of which 274 will be provided as socially rented homes and 190 will be provided as intermediate affordable housing. With sustainability at the forefront of Eco-living Ltd's objectives, the housing has been designed to Code Level 6 in accordance to the Code for Sustainable Homes. To achieve this level, the major aspects that have been designed to the required standards set out in the Code for Sustainable Homes are the materials, opting for materials with low thermal conductivities and low embodied energy, the use of insulated concrete formwork for all load-bearing walls, which will ensure the build of airtight dwellings with very little air leakage. The cost of this ICF system is cheaper than the alternatives of masonry or timber frame when constructed to the Code Level 6. To reduce the embodied energy used,
50% of the CEM 1 Portland cement is to be replaced with ground granulated blast furnace slag. The white goods and lighting systems were chosen to minimise the power demand. The specific heating demands were calculated for each dwelling. A mechanical ventilation system with heat recovery is to be used. And sedum roofs, minimising surface water runoff, have been used on each house. Additionally, the houses have been designed to be structurally sound in accordance to the relevant Euro codes. To ensure that the houses are built to the high quality set out by Eco-living Ltd and the necessary regulations, quality tests will be undertaken during the construction phase of the project as seen in the table. The school is designed to cater for 300 primary school children, with the ability to expand and cater for a further 200 pupils at a later date. The white goods and lighting systems were chosen to minimise the power demand. The specific heating demands have been calculated for both the school and the sports complex. A green sedum roof construction will be used on some areas of the school and sports complex roofs. Alongside the environmental benefits of using a sedum roof, the amount of rainwater runoff will be reduced. A non-green roof will be used over the long span beams to ensure there is less load transmitted into the structures. The classes will be exposed with the use of internal glass windows, which will create an open but safe teaching environment. The energy generation site is to be located approximately 1.1 kilometres upstream from the mouth of the River estuary. This location has been selected because of the large tidal catchment area available, the mass flow rates experienced, the fact that energy can be produced approximately 80% of the time at this location, to prevent exposure to adverse sea conditions, to provide a minimum distance across the river with access capabilities, and the selected site will allow for easy integration with the southwest coastal path. The average volumetric flow rate of the estuary has been calculated, providing the necessary information to design the turbine array. 5 Tocado T200 turbines have been chosen to effectively utilise the flow velocities of the site. The turbines are to be supported on floating frames, fixed to a bridge structure using rollers. All structural design has been undertaken following the relevant Euro codes. Using a flow duration curve based on the selected turbines and the flow velocities in the estuary, it can be seen that the turbines are capable of producing energy approximately 80% of the time. The area in green represents the working velocity range of the fluid flow, and the red area represents that outside of working conditions. At the average flow rate of 2.51 meters a second, the turbine array produces 400 kilowatts, equating to approximately 14,000 megawatt hours across the system per year. This is enough power to supply over 4,000 homes. Including the sewerage waste disposal plants and the combined heating and power wood pellet plants, the total energy output of the village has been calculated to be 16,000 megawatt hours, or a revenue return of approximately £2.8 million per year. The construction of the tidal energy site will be achieved in 4 phases. First, the weir and foundations will be constructed, then the dredging and the installation of the dam structure to narrow the estuary width will be undertaken. This is to be followed by the installation of the bridge support structure, and finally the bridge deck and turbine systems will be installed. A full construction implementation plan has been devised in detail in relation to the overall construction of the Eco-Village project. The project will start with the initial groundworks for the primary roads into the village and to the energy and sewerage plants. 3 weeks after the initial groundworks, the installation of main roads and services can begin. This process of initial groundworks and final construction will then be undertaken throughout the village in zoned stages. This will allow residents to move into completed sections of the village before overall completion, helping the cash flow. The total construction period of the Mothecombe Eco-Village will be around 3.5 years. In addition, the overall estimated cost of the Eco-Village is £140 million. The cash flow analysis has been calculated for two of the main elements of the Eco-Village. These are the tidal energy generation system and the housing. The total construction cost for the tidal energy generation system is £3.5 million, with a construction time of 3.5 years. This system yields an internal rate of return on net profit of 27%. The total construction cost for all of the proposed housing is £60 million, with a construction time of 5 years. This system yields an internal rate of return on net profit of 160%. Using the PRINCE2 project management methodology as a guide, a risk assessment relating to Eco-living Ltd's ability to deliver the Mothecombe Eco-Village project has been undertaken. Eco-living Ltd has carried out a SWOT analysis. To summarise, a key strength is that we are young, motivated, multidisciplinary engineers. Our main weakness is that the company consists of inexperienced employees. A major opportunity is that we are an emerging company at a good time where sustainability is a very current issue. The company's main threat is that we are the first to design an eco-village of this magnitude, creating the potential for competitors to learn from any mistakes made and subsequently progress quicker. So, why should you invest in this project, which would allow us to move forward with the build phase of our proposal? Help this young, dynamic and enthusiastic company produce full eco-communities where residents feel part of their community. Provide needed affordable housing to the South Hams district. Help us to implement groundbreaking environmental technologies. Set the precedent for eco-village design within the UK and around the world. And be part of a movement that will preserve and improve our planet's fragile ecosystem. We have laid the roots. Help us to grow the rest.